Welcome to APICS Extra Live, Smarter Safety Stock with Dave Turbide. My name is Christopher Jablonski, Staff Editor with APICS. Before we begin, I'd like to run through a few details. At the end of the presentation, we'll save time for a question and answer session. If you look at the right toolbar on your screen, you'll see a questions box. To ask your question at any time during the presentation, simply type it in the box and click send. If you experience any technical difficulties during today's broadcast, please call GoToWebinar support at 1-805-617-7000. This presentation is being recorded and will be available at apics.org/extralive early next week. Now it's my pleasure to introduce our speaker for today's broadcast. Dave Turbide, CFPIM, CERM, CSCP, Certified Manufacturing Engineer, is an independent consultant and freelance writer and the author of the Enterprise Insights Department in APICS magazine. He's an APICS CPIM and CSCP Master Instructor with the Instructor Development Program and president of the APICS Granite State Chapter in New Hampshire. Dave is passionate about manufacturing, planning, scheduling, inventory, and supply chain. So everybody, please give a warm welcome to Dave Turbide. And Dave, you can take it away.
Thank you, Christopher, and welcome everyone. We're very pleased to have a good crowd out there today, and we intend to make this time very well spent for you. Let me apologize a little bit up front. I have a touch of the spring flu that's going around, so my voice is a little bit scratchy. I will try to be careful and just don't get too close to the screen. You should be okay. All right, today we're going to talk about safety stock, and I've broken the presentation down into three sections. I'm going to start with just a quick overview of what safety stock is for, and then talk a little bit about what people normally do. And when I say people, I'm referring to the hundreds of companies that I've worked with over the last 33 or 4 years, and all the different ways that they approach safety stock. There are some common elements, and we'll go through that and talk about some of the good things and some of the not so good things perhaps. And then the real meat of the program is in section 3, where I'll take you through a step-by-step suggested process for getting control of safety stock and making it work for you. So that's where we're going to be today. Start out with the theoretical definition of what safety stock is for, and this comes right from the APICS dictionary. And safety stock is defined as a quantity of stock planned to be in inventory to protect against fluctuations in supply and demand. Now, there's really only two reasons to have inventory. The first reason is as a decoupler, and you'll find a lot of information about decoupling points and decoupling inventory in the APICS literature and in the APICS education. And that concept is just to position inventory for its primary purpose, and that is to uncouple or to act as a shock absorber, if you will, between supply and demand. So if you are a ship from stock or make to stock kind of company, for example, you would have finished goods inventory that would act as the interface point between supply and demand. Demand would draw from that inventory at whatever pace and timing and quantities and so forth that it requires, but the resupply side, the supply side from the manufacturing, can refill that inventory at whatever quantities and timing are appropriate for efficient operation. Okay? In other words, you don't have the factory being driven by the pace of demand. Now, if you can do that, then and you're very fortunate and very good at manufacturing management, and that's the proverbial or theoretical demand-driven organization, where you have production set up to produce parts at a coordinated rate with demand, and that's kind of an ideal situation. But most of us are far from that ideal, or some distance from that ideal, and we need a decoupling point. We use inventory to do that. So we'll make more than we need any particular day, and then sell them off over the next few days or weeks, and then replenish when it gets down to a certain level. Now, beyond that basic decoupling inventory, additional need for inventory can be categorized as safety stock, and this is the base definition. Now, most companies, most people, most computer systems will offer other drivers of inventory, things like shrinkage factors, yield factors, and that kind of thing, which will also drive additional inventory to cover for variation or things that don't happen as they should. We're not going to talk about those today. We're going to talk about safety stock, and that's the extra inventory that's in there to cover against fluctuations. Now, the kind of fluctuations or variation that we're covering are these finished goods. Now we have the possibility of variation on both sides, both the demand side and the supply side. So on the demand side, we're looking at primarily forecast error for finished goods. So the actual demand is different from what we expected it to be when we put our plans and our inventory plans together. So this will give us a little bit of room to cover some of those variations. We'll talk a little bit more about that shortly, so that we don't run out when that variation happens to be a little bit higher demand than we expected. On the supply side, we can have disruptions and variations on the supply side as well, schedule changes, scrap and yield that we didn't expect, things being delivered late, that kind of thing. So safety stock will help cover some of that variation as well. Now for components and materials, same kind of thing. In this case, the customer or the demand side is not the actual customer, but it could be finished goods inventory, if you want to think of that as a customer, or it could be the production line that's the customer for sourcing or purchasing. And the supply side then would be the factory or the feeder line or the supplier, and that can be responsible for variation as well. Things come early, come late, more or less than was expected, or don't come at all, or they come and they're not usable, that kind of thing. And I've listed a couple of other general categories here that really are part of what we just talked about, but the source of variation could be something like loss, damage, theft, unauthorized use, unreported use, just plain errors, reporting errors, or lack of reporting, those kind of things. And I also listed bill of material errors, which can cause fluctuations, particularly if you are back flushing. And I'm not going to rail against back flushing right here and now in this presentation, but it's a very dangerous thing. It's convenient, and I can understand why a lot of companies rely on back flushing, but it is a dangerous practice in terms of inventory control and the need for safety stock to cover variation. If you have an error in the bill of materials, you will be issuing on the system side what the bill of materials thinks is needed. However, what is actually used may be different, and that will cause your inventory balances to be inaccurate, which brings you up into the previous bullet, and that is you've got bad inventory records, and then everything flows from there. All right, so that's enough discussion about variation. Let's talk about how people normally handle safety stock. Now, let me preface this by saying just about every company out there in the world does have some kind of safety stock. Sometimes it's very informal, sometimes it's very rigid and formalized, but I don't think I've run into a company anywhere at any time in all of my years out in the field that did not use safety stock in some way, shape, or form. So here's what I see. In a very simple example, we have our supplies, our inventory stacked up against the wall here, and we draw a red line on that wall before we stack that inventory up there, and that's, you can see the edge of it there sticking out. And we will use those supplies over time, and the deal is when we see the red line, we'll place the replenishment order. Okay, so I can see the line. I call up the supplier and say, I need another shipment of these blue boxes, and why don't you get that going right now, and hopefully it'll get here before I run out. Well, what really happens more often than not, or not more often than not, but an unfortunate number of times, is we do actually run out, and the resupply hasn't arrived yet. So what happens next? Well, the thing that happens most often is you just grab that can of paint, you paint another line a little bit higher, right? And we go through it again, and the next resupply comes in, and we stack it up against the wall, and we start using it, and it gets down, and I can see the red line. I order some more, and the resupply comes in before the rest is gone, sometimes. The next time I run out, guess what? I just paint the line higher again. Now, this goes on pretty much routinely. And my question is, when and how often and why do you go in there and paint over that red line and bring that level back down? And the answer is seldom, if ever. You know, maybe once or twice a year, the CFO or the CEO or the chairman of the board or somebody will come down and say, we have to reduce inventory. And it's not a given, not an option. It has to be done. So when the supply gets down to the point where you can see the whole top line, you may get out the steel wool or the can of white paint and obliterate the line and place your reorder when it hits the second line. And at some point in time, that line's going to be back. Okay. So these informal or these unmonitored safety stock policies, which is basically what this is, tend to grow over time. And very seldom do they get readjusted back down, which is especially troublesome if the unusual usage was a one-time event. You know, that one time we ran out, or maybe that's not the case anymore, that we're likely to run out, but we very seldom go back and reevaluate and reset those order points and safety stocks. Now, what you have in front of you now is the classical or the traditional order point diagram, which is just a graphical version of what I just showed you with the blue boxes. In this display, let me get my pointer out here. In this display, we have usage over time up here, right? Inventory on the left, y-axis, the vertical axis, and the time dimension being horizontal. So through time, we're going to use this inventory at some given rate. And we're assuming a steady rate here, just to keep things simple. And really don't have any issues until we reach this trigger point, the reorder point. Once we place that reorder, now we're at the mercy of statistics and fluctuations of demand. Ideally, that reorder will come in right when it's supposed to, at the quantity it's supposed to, and will prevent shortages. More often, well, not more often than not, but often enough, we'll have the situation where, oops, trying to change my pointer here. We'll have the situation where demand will be higher than expected during that time at risk, during the resupply lead time, which will drive us down to negative. That's why we have safety stock in there to cover for it. Or sometimes the resupply won't arrive on time, and we'll be digging into that safety stock to cover until that resupply actually does arrive. So that's order point safety stock in the traditional display that you'll find scattered throughout the APICS literature and a lot of other places as well. And that is the typical case for an order point kind of system. Now, order point works fine for finished goods because we have a relatively steady demand, and we can capture the statistics. We can look at forecast error or variation over time. We can run the math and calculate mean absolute deviation or standard deviation. And then there's a set of tables that we can use to look up what level of service we can expect from a given level of safety stock, or vice versa, how much safety stock we need to deliver a given level of service. We'll talk more about this in just a few minutes. But I have the math to do that, and it's a fairly straightforward process. If I can measure that variability, then I can go to the tables and I can set a safety stock level to deliver a certain percentage of service. Or conversely, you know, and it's kind of neat the way this works, because I can go to senior management and say, how much service do you want? How much risk of a stock out are you willing to bear? And they will say, 99% service level or 100% service level, at which point you try to tell them that you can't afford it. They don't believe you. You'll send you back to your computer and your tables and figure out how much safety stock it's going to require, and then you can go back to the senior executive and say, look, I can give you 99% service, but we're going to have to build 3 new warehouses and invest another $20 million in safety stock. Now, that's obviously not going to happen. So then the exec will say, well, what kind of service level can we get for another $2 million or whatever? So there'll be some kind of a back and forth. So that's the or bullet on this slide that says you can calculate the service level given a certain investment in safety stock. Right? So you can work the tables both ways and come up with a policy or a strategy for taking care of that. So for components, those things that we put into the manufacturing process as opposed to finished goods, we don't have that smooth, steady demand or that reasonably steady demand with the statistical variation above and below. What we have for components is lumpy demand. Okay, we'll go to the stockroom and we'll pull 100 and assign them to that work order. And then we may not use them again for another 2 weeks, and then we'll go to the stockroom and we'll pull out 250 for the next batch. All right, so that kind of demand does not lend itself to the statistical analysis that we use for finished goods. So I really can't apply that same technique for components. So what do companies do? Well, they can still use order point and safety stock and all that, but it's not very effective. You end up with a whole lot more inventory for a whole lot longer time than you really need to get the job done. Companies, and there are tens of thousands of them around the world, companies have adopted things like MRP, Material Requirements Planning, which will calculate what the demand is expected to be out into the future, and then put a plan together for the acquisition of the components that you need to meet that demand and bring them in just before they're needed instead of just after they've been used. And that's really the power of MRP, and that's why it's so successful and so important, is it gives us this great tool to manage inventory for components and raw materials. Now, in theory, if you read the literature, read the theories, you might get the impression that you really don't need safety stock for MRP planned items, for those dependent demand items. And in theory, that's true. Okay? If we can put our master schedule together and lock it in place through cumulative lead time, and we have no errors in our bills of material, and we have no errors in our inventory records, and everything always comes in on time in the proper quantity, and we don't have any excess scrap or yield problems, then sure, I can operate with MRP without safety stock, and I'm really in a just-in-time environment other than like lot sizing considerations. Now, the world doesn't work that way. We all know that. So companies do use safety stock for component items. And there really isn't a defined technique for safety stock on component items like there is for finished goods, like we just referred to with the statistics and the tables. So we need to develop some, let's call them manual or empirical methods for doing that. And I'll talk to you about that in section 3 here in just a few minutes. So the usual practice, no policy. If you want to be polite and flattering, you can call it experiential. That sounds a whole lot better than no policy, right? So that's the boxes stacked up against the wall with the red line. It says, okay, we'll take a stab at it. when we run out, we'll throw a little more inventory in there. If we run out again, we'll throw a little more in, and when it stabilizes, we'll just ignore it and do something else. So inventory tends to grow uncontrolled. I use the word haphazardly here. That's probably not fair. But in any case, a lot of companies manage their inventory this way. And it's unfortunate because they have too much inventory and not as good a coverage or service level as they really intend or as they could have. So moving down from there, companies that have installed an ERP system will often use safety stock factors in those planning systems that are whatever the consultant recommended or whatever the default was in the software when they installed it. So there may be some thought put behind this at the beginning when they do that transition. If they're not so overwhelmed with data cleansing and data conversion and all that, they may actually take some time and put some thought into it and come up with some policies and then put some safety stock numbers into those computer files, and then the system will use those in planning and managing inventories from that point on. Quite often, though, those factors are hardly ever adjusted and only adjusted typically under the same policy as the first bullet, and that is when you run out, you might throw a little, raise that safety stock number a little bit. And if you run out again, you'll raise it a little bit. And when you stop running out, then you just ignore it. All right, so most companies do not have any kind of a systematic review or management of safety stock, and that's really what's driving this whole presentation, this whole discussion. So companies that do look at safety stock policy and do try to manage it will often use an ABC analysis as part of that process. And what that is just, and this is defined very well in the APICS courseware and the APICS literature, and that says we're going to look at our inventories, we're going to rank them in descending order of annual dollars, or annual usage. I would say dollars here, think euros, dinars, whatever the local currency is, but a currency modified value of annual usage. So we'll take the total number of units that move through inventory in a year times whatever the unit cost is, and we'll do that for all the items, and then we'll sort them with the largest first and then the smallest last, and then we'll go down through that list and actually we'll compute percentage of each one. So the first item is 6% of our entire usage for the year in money terms. And the second item is 2.5%, and the third item is 1.25% or whatever it is. And then we'll add up the percentages. We'll get a cumulative percentage. And then we'll draw a line at the approximately 20% or 80% of the dollars, which will turn out to be around 20% of the total number of items. We've got 1,000 items. First 200 will probably be 80% of the dollars that flow through the plant or the warehouse. That's ABC analysis. So the first 80% of the dollars is 20% of the items. The next 50% or 30% of the items is 10% of the dollars, and the last bottom half of the items is another 10%, plus or minus. And then you can draw the lines at 70% or 80% or whatnot. But the idea is to rank the items into groups of the biggest dollars, the smallest dollars, and the in-between dollars, and then we can set different safety stock policies for each of those groups. The big dollar items, we want to manage them more tightly. We want to have less extra inventory if we don't need it, so we're going to put lower safety stock requirements on those items. The nuts and bolts, bits and pieces, that bottom, the C category in this example, that bottom 50% of the items, we're going to probably put a generous safety stock policy on those, because even if we double the value of inventory, it's only adding another 5 or 10% to our total inventory, so we're not going to worry about that a whole lot. Okay, so that kind of logic, where we'll group the items according to how important they are by whatever criteria you determine, and then apply different safety stock policies that way. Again, whatever is done, if it's only done when the new system is installed, or it's only done one time and then everybody forgets about it, that's really not going to be overall beneficial for you, because it tends to revert to experiential, because that's the way we operate. If somebody isn't watching that and doing it regularly, then it's going to grow. It's going to provide less service than we really expect and not do it very efficiently. So sometimes actually safety stock is actively managed, and that's what we're driving for in this presentation. We'd like to show you a simple methodology for approaching this. Simple but not necessarily easy. You need to pay some attention to it. You need to work at it a little bit. You need to keep it on the agenda for regular review, and that's what I'll walk you through in the remaining section. All right, so here's that process. How do we reduce safety stock without increasing shortages? Now, the purpose of safety stock is to protect against variation. And those are the things we don't know, or the things we can't control. Forecast error, scrap and yield and things like that we can't predict, or maybe we can predict but we just can't do anything about it. But that's what we want safety stock for. So we have to relate that directly. Okay, we have to understand the extent of the variation and then put in an amount of safety stock that's appropriate for that amount of variation, in context of what kind of a service level we're shooting for. Okay, so we do that. We apply what we think is the proper amount of safety stock, and then monitor, verify, and adjust. This is an active process. It is a journey, not a destination. Okay, add it to your cycle counting efforts. It's something that goes on continuously, not necessarily every day, but on a regular basis, to be reevaluated and reset and managed. And that's the key to success. Then we'll talk about an improvement step, which will allow you to bring down the inventory. So those previous things really have to happen first. Then we can look at improvement, and we can take an intelligent approach to reducing inventory without increasing safety stock. And what it comes down to is this triangle that's on your screen now. There is a direct relationship, a direct tie between inventory, service level, and variation. Okay? In a stable situation, whatever it happens to be, for a given level of inventory, read that as safety stock, and the existing amount of variation, that will deliver a certain level of service. We cannot change any one of these factors without changing at least one other. So if I want to reduce inventory without hurting service, I have to reduce variation. If I reduce variation and I don't reduce inventory, my service level will go up. Okay, so I can change any one of those factors. It's going to have a direct effect on one or both of the others. That's where we're coming from. That's what we have to keep in mind as I go through this process with you. Now let's look at the process. First of all, divide and conquer. Finished goods and raw materials are different. We've already seen that. So we're going to have different policies, different strategies for those two kinds of inventory. Now, within those two major groups, there's probably other subdivisions that we want to pay attention to when we set those safety stock policies. For example, we may have key items that are unique in the marketplace and very important to our reputation, and we cannot afford to have back orders and shortages on those items. Because of their importance, we may have more liberal safety stock policies. We'd be willing to invest more money in extra inventory to have a higher level of service. We may have some other product lines or other customer sets where we're not that concerned. If there's a backlog or a back order, it's not a big deal. It doesn't really hurt us a whole lot. The customers are willing to wait. Then we can live with a lower level of service. Okay, so that's the kind of logic we want to apply to this divide and conquer, these subcategories. Now, you all probably know that I write the Enterprise Insights column for APICS Magazine, and I wrote a column earlier this year about safety stock, which is what actually triggered this webinar. But I got a note from a reader, and he asked not to be identified, but he works for a Fortune 500 company, and he is responsible for safety stock, and he described a process that he goes through, basically asking me, are we doing it right? Are we doing good things? Are we doing, can we learn from what other companies are doing? And they're doing an excellent job. And he shared with me some of the things that he does, and one of them that I wanted to show you is that his items are divided into 4 groups. And they are high volume, low variety, high volume, high variability, low volume, high and low variability. And those are excellent categories because you can clearly see with that triangle in mind that each of these groups will likely have different policies in terms of the service level and in terms of how much inventory we would be willing to invest in. Okay, so this is the kind of logic, the kind of thinking that you need to apply to this. Look at the items that you have. I don't know if it's 500 or 5,000 or 5 million items, whatever there are. There's got to be some pretty simple ways to break them down into groups that deserve different policies, different strategies for safety stock. All right, so you do that, and then set the objectives for each group, either service level or total amount of safety stock that you're willing to spend for this group. Okay, and there's a trade-offs back and forth. Remember the triangle, right? So come up with your strategies, and you can actually go out and test this. You can run some fairly simple math, or actually I sat in on a webinar, kind of a demo last week. A company called Smart Software. I'm not here to promote the software in particular, but it's a forecasting software, and they have some really outstanding simulation capabilities around this this process, where you can set a service level, and it'll tell you how much safety stock you need, or you can, and it'll divide the items within a group and rank them according to the service level you get for certain kinds of safety stock. So all of this logic is built into that simulation. So that's something you might want to look at if you're really into this. You can do it on the back of an envelope, but you need to think about what your strategy should be. All right, whatever you decide, now you can take the next step and you can apply it, and I'll come back to that last bullet in a minute. And you can apply it and then try it and see what happens. See if you achieve the service levels that you expected, and then we can make adjustments from there. It assumes that you're going to know the variability. If you do know the variability, in other words, you've got, in the case of finished goods, you've got those statistics and you've calculated the standard deviation and so forth, terrific. Your job is already half done. If you don't, then take a guess. In the case of raw materials and components, for example, you're just going to have to wing it. Do we ever run out of this guy, or do we seldom run out of this guy, or are we running out all the time? And that'll give you a clue of whether you need to set your safety stock higher or lower, or leave it where it is. And then you're going to start measuring and start paying more attention to it in this continuous improvement process, and take it from there. So this is just a starting point. You will get, stockouts will get your attention. That's never a problem. When you run out of something, alarms go off, people get upset, customers are disappointed. Those are very visible. So you can take action. All right. If we run out of this guy, every week or two, then obviously we don't have enough safety stock. The service level is too low. So we can start measuring that. We can look at how many times it was used, or the total volume during that period of time, and we can calculate what the service level is. We can set a higher service level, and then start adding safety stock until we achieve that level. So it's kind of a trial and error process. Works really well with shortages because they're visible and you can see them right away. It does not work as well with too much inventory because you just don't run out, and that could be perceived as a good thing except if it's too good. Okay, that particular item or group of items may only really deserve, in your management judgment, a 95% service level. If you're actually running with a 98% service level, you've got a lot more inventory there than you need. You might be better off applying that inventory investment to some other items that are not achieving their objective. Okay, so we can start sorting out the items that are too heavily safety stock. I want to say buffer, but that's not the way that term is used in APICS. They're too heavily protected against shortages, too high a service level, and then you can apply whatever savings you have from bringing them down to where they should be to cover the items that are not getting adequate coverage. Make sense? All right. All right. So we want to stabilize. We want to take our first cut at it, measure, monitor, adjust, and we want to get it operating to the level that we like. Okay, if we've established safety or service levels at 92% for this group of items, 96% for that group of items, 95% for that group of items, whatever it is, we'll look at each item, we'll look at the actual amount of safety stock and the shortage or service level performance, and we'll make adjustments until we get it where it needs to be. And we'll redistribute the safety stock investment to the proper places so we can achieve that stable, that service level that we wanted. All right, so that's all set up. That's all getting started. Now, for the improvements, and we may actually be able to reduce inventory a little bit if we have a lot of things that are over protected, but chances are, you'll be able to stabilize it somewhere near your target service levels in that first round. Now what we want to do is reduce inventory without reducing service level, and we do that by looking at the third leg of the triangle. Okay, we've only been working with the trade-off between service level and inventory. Now we want to bring variability into it. In order to reduce inventory without hurting service level, we've got to do something about variability or variation. All right. So now we put our detective hats on, and we have to go after the variation. Identify the source of the variation. Is it on the supply side? Is it on the demand side? Do our Ishikawa fishbone diagrams or whatever other cause and effect techniques you want to apply to it to find the root cause of that variation, and then work at reducing it. Okay, we've got some key suppliers that are not terribly reliable, and they tend to deliver early or not early. That's not a problem so much. They tend to deliver late, and it's unpredictable. You should start working with that supplier or those suppliers to improve their on-time delivery performance. If we have some items that we have some issues with yield or scrap rates, work with the process engineers, work with the quality folks, and try to get those fluctuations down to something more manageable. And then we can, by doing these actions, reduce the variability. That will allow us to reduce the safety stock without harming service level. Okay, keep that triangle in mind. Now, the last step here, and this is something that sometimes will escape us as we go through this process. Okay, we've set our policies in place, we've done our measurements, we've resorted and stabilized, and we're getting a service level that we intended. We have a good handle on where our safety stock is. Now we take the next step and reduce variability, and we want to reduce inventory. Well, if you're using MRP or another computer system to trigger and manage your replenishment process, you're not going to be able to reduce the inventory until you reduce the safety factor in that computer system, right? That's one of the things that kind of bites you in the backside with a new MRP or ERP implementation. Companies will rationalize or justify millions of dollars for a new system. A good deal of that justification is often reduced inventory. So they will put the system in place, they'll convert the data, They'll put in their safety stocks and all that appropriate to keep the company in business and develop the service levels that they need. And then they're surprised when inventory actually goes up and heads will roll. And that's unfortunate because it's something that normally happens in most ERP system implementations. Your inventory will not automatically go down just because you've got a new system. It won't go down until you take positive action to change the way things go. And you do that through this kind of methodology. Understand the source of the variation, and then when you've controlled the variation and reduced the variation, then you can take the safety stock and the yield factors and the shrinkage factors and those things, take them down. That's what reduces the inventory. So that's where the payoff comes from. All right, so here's a recap of the methodology. Group the items and come up with policies or objectives for each group of the items. Calculate and apply the safety stock the best way you can, and then start monitoring and managing and see if you've achieved the level you expected. If not, then make adjustments. And generally speaking, you'll be adding or reducing the amount of safety stock in various groups. Hopefully, you'll be able to do that within the same investment that you had before. In any case, you'll know what you're getting and you'll know what you're paying for it by each group and at least partially each item within each group. And then you can start through the improvement process. Find the cause of variability, reduce the variability, and reset the safety stock level, and then repeat. And that's it. That's the process. So what I'd like to do at this point is open the lines for questions. I guess you've been typing in your questions all along, and Christopher, you're going to relate some of those questions to me, and we'll see if we can get some answers up here.
Absolutely, Dave, and we already have several questions coming in. We have a nice big audience, so just as a brief reminder, if you would like to ask a question, just look for that questions box on the right toolbar of your screen and click send. So let's get started, if you're ready. Our first question is, stock quantities are affected by pilferage and obsolescence. So does safety stock take these under consideration?
Let's talk about pilferage. Pilferage is one of the sources of variability. So if that's something that's happening often enough that we can measure it and monitor it, then yes, we can put safety stock in that will cover it. Not so in the case of obsolescence. Obsolescence is by definition a one-time event, not something we can measure and monitor. But I'm glad you brought that up because that's another factor in the safety stock management world, and that is we put safety stock in to cover during normal operations, however you choose to define normal. And that's what it's for. But if I have a part or product that is at end of life, I don't want to be stuck with whatever extra quantity is in there for safety stock at the time that item becomes obsolete. That's something I'll have to write off or throw away or find a way to recycle. So, as the product goes through its various stages of its life cycle, I may want to revisit that safety policy. Okay, so when it's in its early cycle, when it's in the growth phase, and volume is increasing, it may move it from one of those categories to another. I had the 4 categories that reader sent me. That was looking at high volume, low variability, low volume, high variability, those kind of things. The different phases of the product's life cycle could move it from one category to another. So that's another thing you need to watch on, and I'm assuming that this is going to be a regular process for you. I don't know whether you'll have somebody that's dedicated to it full time, which if you have enough inventory would be very justifiable, or whether it's something somebody will look at once a week or once a month or once a quarter. Whatever the cycle is, you need to revisit those categories, make sure that the items are in the proper categories according to the volume and risk of variability and so forth that they fall into. So an item that's been in its maturity stage for some period of time is probably fairly stable. Variability is probably relatively modest. would probably have a safety, at least it should have a safety stock policy or strategy set for those conditions. Now when it starts to drop off, it's in the decline phase and heading towards obsolescence, I may want to take that safety stock out completely so that I'm not stuck with extra inventory when it finally does become obsolete. Okay, so in your engineering change process, when you're looking at product lifecycle issues, that's something that needs to be factored in. Certainly safety stock strategy should be on the checklist of things to do when you are preparing an item for discontinuance or for obsolescence.
Great, thanks, Dave. Our next question comes from Steve, and Steve's asking about the time periods you might look at for understanding variation. So might you recommend weighting the more recent history better or greater than the more distant past history?
Great question, and something I neglected to bring up in the discussion was, or I didn't point to it specifically as I should, and that is we are protecting ourselves for variation during resupply lead time. So whatever the lead time is for that resupply process, if it takes a month to get a new supply in or to make a new supply of whatever object we're looking at, then I'm interested in the amount of variation that occurs within that lead time, within that that replenishment time. So that does put a little shade of difference on it. If you're looking at when you're looking at variability, you have to have some period of time in mind, because variability will be different for a long period of time versus a short period of time. So that's point one. Point two, do we look at more recent data? And there's no simple answer for that, and it's really the same answer when we look at any kind of a forecasting process. And if you've gone through the APICS CPIM education in particular, there is quite a bit in there in terms of various statistical techniques that can be applied to the forecasting process. So we talk about exponential smoothing and moving averages and that kind of thing. And the open question, and the one that's not specifically answered in that literature and really can't be in a general case, is which is better. And that depends on the scenario, on the circumstances, and that is addressed in the APICS literature. And that is, if I have a relatively stable process and the variability is relatively low, and I have no reason to suspect that it's going to change a whole lot, then I will use a long period of time for averaging, for smoothing, okay? And I won't put a lot of extra emphasis on more recent data, because I want the stability. I want that statistical analysis to be stable and relatively unchanging. If I have a process or a demand or a supply or whatever that's highly variable, then I want to put a lot more weight on more recent data, because I'm expecting a lot of variability, and I want to make sure that I capture any change in the process. All right, so that's kind of a non-answer, but it's the best I can give you in the general case, and that is, if I have reason to suspect that the variation or the demand itself may be changing, then I want to use a short number of short cycle if I'm doing a moving average kind of thing, or a high alpha factor in a exponential smoothing technique. But I want to put more emphasis on more recent data if I'm expecting or at risk for a change. Whereas if it's a relatively stable process, I'm not expecting a change, then I can use the longer averages or the more stable data, but that increases my risk of missing a change when it actually comes. So it's all trade-offs.
All right, and moving right along, our next question is, are you aware of any easy key performance indicators or KPIs that can measure the health of your safety stock?
The only real measure is service level. And like all indicators, it really has to be in context. This is something I've written about a number of times recently, blogs and things. But measurements really have to be multidimensional. You know, if I tell you that my company has $1 million in inventory, that's information, but it's not useful information. If I tell you that my company has $1 million of inventory and that represents 12 turns, that says my cost of goods sold for years is 12 million. I have $1 million in inventory. That's 12 turns. That's a 30-day supply, generally speaking. That's more information. It's more useful. It really doesn't tell the story. You know, if I have a company that's doing 12 turns a year, you know, I have to look at competitors and industry averages and other industries and all of that to decide if that's good or bad. But further, I have to look at what kind of a service level. What's my record with stockouts, with back orders, and that kind of thing. Okay, and is that acceptable? Right. So, you know, I can take this $1 million inventory, and as CEO or chairman of the board, I can come out and say, you know, we need to reduce that 20%. And my workers are very loyal, and they trust me, and they go ahead and do that and achieve that 20% reduction. But at what cost? Okay, it's going to save me money on one side, but if I have a lot more expediting, if I lose business because customers aren't willing to wait when they get a back order and they order something and it's not available, that's going to cost me more probably than the $200,000 investment that I saved by reducing the inventory, right? So it's always got to be in context. So yes, I want to look at service level, but service level in conjunction with inventory investment. I can always increase service, just put more inventory in. I can always reduce inventory, just stop buying, stop making, you know, sell off what I have. But it's going to have an impact on service levels. So I can't really look at one side or the other without comparing them and seeing the relationship between them. So short answer, what's KPI? It's service level, but it's service level in relationship to the amount of inventory investment I have. If I can maintain the inventory level and improve service, that's a big win. If I can reduce inventory without reducing service, that's a big win. If I reduce inventory and service goes down, I haven't accomplished anything.
All right, and our next question comes from Amy. It's actually more of a hypothetical scenario, but in their factory, builds are requested to close in a week earlier than needed, and this serves as a buffer. Would you consider this safety stock, even though overall you're not actually building extra stock, or would you more consider this a safety lead time?
I'm not sure I tracked that. Read me the question again.
In this scenario, the factory is closing a week earlier than needed to serve as a buffer. Would you consider this extra lead time sort of in the area of safety stock, or is this a different category entirely, such as safety lead time?
Yeah, that's really safety lead time, and that's something that most companies use routinely for purchased items. You call a supplier and say, how long does it take to get this particular part? And they say 2 weeks. So what do you put into your MRP system as a lead time? You'll probably put 2 weeks plus 2 or 3 days, or maybe put 3 weeks in there. So what happens is you need something 2 weeks from, or a month from now. Instead of ordering it 2 weeks from now, 2 weeks before you need it, you'll order it 3 weeks before you need it, and you'll tell the vendor to ship it so it arrives a week before you need it. And that way, if they're late 2 or 3 or 4 days, you're not going to be caught short. Technically speaking, that is a lead time buffer. Practically speaking, it's also going to be inventory, because that stuff is going to come in early. It's going to go into stock. It's money spent. It's inventory, physical inventory that you can touch and count and have to pay for. Okay, so it's a shade of difference. It's mostly a language thing, but yes, what you described, if I tracked you correctly, if you're completing a customer order a week ahead of when you're going to ship it, it is technically a lead time buffer or a time buffer, but in actual fact, you're going to have an inventory buffer there as well, right? And whichever terminology is more comfortable for you, it really doesn't matter. That's what's happening.
All right, and our next question is from Greg, and Greg asks, Greg says he's surprised that constraints hasn't been mentioned yet as a cause of variation in supply. Would you say that safety stock in this sort of environment makes the supply problems better or worse?
Wow. Yes. It depends. That's like the consultant standard answer, right? It depends. Constraints. All right, we have a limited supply available, and no matter how much we order, that's all we're going to get. That's really not a safety stock issue. It's more of a planning issue. When you do your resource planning and rough cut capacity planning and that kind of thing, you need to recognize those constraints and build a plan accordingly. And as long as that constraint exists and you know what it is and you plan appropriately, then safety stock is not a factor in there at all. If it happens occasionally and you don't know it's going to happen, and it shows up as a variation in supply, then yeah, I guess you could safety stock to cover it, but I'm not sure how you'd predict that. So, good question. I'm not sure I have a good answer for you.
I think maybe that's sometimes the only answer. I think we have time for either one brief one or possibly, I'm sorry, either two brief ones or one more longer question, but here we go.
Okay.
Do you think are there any special considerations when you're dealing with custom components or make-buy decisions with safety stock?
Yeah, safety stock is really not or shouldn't be a factor for a one-off, a unique product or a unique material or component. You only order it one time. It comes in or it doesn't. And it's not where, safety stock is something you apply to a regular process that's going to apply every time you make or buy or sell a particular object or item. Right? So if it's a one-time deal, we're an engineer order situation or a make-to-order situation. We don't order it or make it until it's ordered by the customer. We get it in one time. We use it. It goes out. It's not like safety stock is going to help you next time because you're not going to do it again, right? So, if you see the need to buffer, you've got this unique order for 500 of something, and you're going to only make it one time, and it's unique components and all that, then you'll order just what you need unless you have some reason to suspect that, if you order 500 and you receive 500, only 480 of them are going to be usable, then that's a yield or a scrap factor, not safety stock. Safety stock is really about variation. And if it's something with an assignable cause that you can predict, then you need to use one of these other factors to do it.
All right, and I think we can possibly ask one more quick one. Can you talk a little bit about some of the pros and cons of using a system-generated safety stock?
Yeah, these systems like the one I was just telling you about, the biggest advantage they have, well, a couple of big advantages. One is it's a continuous process. Okay, so it enforces this idea of actively managing safety stock, and you don't fall into the trap of we said it when we installed the system 10 years ago. Nobody's ever looked at it since, except when we had problems, and then we pumped it up. So biggest advantage right there is it embodies a continuous process. It's continually looking at variability and service level and all of that. Second big advantage I can see is this simulation capability that I was talking to you about. So as you go into this process and you try to make these decisions and strategies and so forth, you can do those trade-offs in the simulation. So, all right, we want 98% coverage for everything, and you turn the crank and it shows you it's going to cost you $18 million. You say, no, that's not going to work. So then you can start playing with it. You say, we can afford this much. What's that going to buy us for service level? And you can start trading off between different kinds of items and different marketplaces and all that. And you can simulate all of this and come up with a strategy that represents the best approach for your company in its situation and its customers and its products and so forth at that point in time. and then once it's embodied into the forecasting system or the safety stock calculator, then it will be maintained throughout time, and the systems will warn you if something gets out of line or the variation level changes dramatically. You'll see that, and it accommodates it. So I see that as two big advantages. And the software isn't as expensive as it used to be, as most technical things tend to follow Moore's law and get cheaper through time. But some companies just can't afford it, or don't have the internal wherewithal to manage that kind of software. Well, here's some things we talked about today that you can do without software. Do I think the software is worthwhile? Absolutely. Is it necessary? No, not really. You can do these things by hand, but it's more work and not as effective.
All right, Dave, thanks. And with that, I think we'll have to call this APICS Extra Live to order. So thank you very much, Dave, for your time today. And thank you to all our participants.
Anybody listening, if you want to follow up with another question, my email address is on the screen there. Or I think you could reach me through the APICS magazine as well.
Absolutely. Thank you for offering that, Dave. So this concludes today's edition of APICS Extra Live. All content and materials in this edition of APICS Extra Live are the property of APICS and Dave Turbide and are protected by the United States and international copyright laws. All rights are reserved. Thank you all for participating.